All right, so we're going to start a new topic. So I'm not going to go too intense this morning because we're almost at the end, but we can
Okay.
just go through and get a gist of what we'll be doing, or even more than a gist, right? So
Okay.
we'll be looking at sets and Venn diagram real quickly. We're not going to spend an entire, say, 2, 3 weeks, and this is just, if we can finish this by Monday, that would be great. So let's
Okay.
just start.
So, okay, sir.
So sets Venn diagram. So as it says right here, we use the idea of sets to classify numbers and objects, and we use Venn diagrams to illustrate these sets. The sets A and B consist of numbers taken from the numbers 0 to 9, so that set A and they pick out some, and set B and they pick out
And set
some, right?
info.
So out of this set, and you'll see where they refer to this um, bigger set or the
Over there.
original set as the universal set, and then you'll see where
Mm-hmm.
they make
For the
smaller set
smaller set.
out of it, and they will label it and say, okay, set A, set B. You will see later where they refer to these points, these numbers are as elements in the set. So going through, and what they do oftentimes is to create what is known as a Venn diagram, which is just a graphical way of showing the sets, right? So
Okay.
anytime when they ask you to illustrate the sets using a Venn diagram, you first of all you identify the number of sets. In this case, it's two sets, um,
Mm-hmm.
right? And then, of course, you have the universal set, but we'll focus on the subsets, set A, set B, that come from the universal set. And then now, whenever they ask you to draw anything, you start at the intersection. So what you'll see here is that set A has four in it,
And
as
set B
two,
also has 4.
yeah, and set B has four. So what is common to the sets? So in this case, we just have two, but it could be three, four, five, could be any number of sets. What is common to it, you put it in the intersection, which is where the overlap. Set A and set B
Okay.
overlap, right? So you put it there. Then now you form the rest of the diagram. So we know that set A also has 7 and 9. So you put 7
Yes.
and 9. The 4 would have already been there. So set A is complete in terms of the representation. 7, so 4, 7, 9. So everything is there. So set B now, we just need to include 1, 2, 3, and 5 because 4 is already there.
Mm-hmm.
Right? And that's what they did. and then
Okay.
and then of course the universal set, which is represented by this entire box, needs to include the other
The
element
others that are
of
not included yet.
the exactly. So we see where they include those on the outside of these two sets, right? So when you count it up,
Okay.
1, 2, 3, 4, 5, 6, 7, 8, 9, right? And of course they had
Okay.
included zero. All right. So they come now with some notes, and they say, all right, note that where the overlap, or where you have elements that are common, that is the
All the
intersection,
intersection.
and they show the gray, and then the union is everything that's in both set A and set B. And as I say, it could be any number of sets, right? Could be A, B,
Okay.
C. And if you put the union sign, which I should show you, they're just saying, okay, everything that is within. So a union of two sets is everything that is in the two sets,
Both sets.
right? And of course, they represent the intersection one time. Some people have a thing where they may be tempted to put what is common to both sets twice, but no, you just put it
Mm-hmm.
one time, right? So in the
One.
case about where we had four in both set A and set B, when you do the union, which would be 1, 2, 3, 4, 5, 7, 9. You notice that I do say 4 again, right? Because 4 is already here. So just make note of that. Um, and this is just as I do it. See it here, and then them go all the way up. And then mention 4 only once. And then make a note. I say it is not repeated when writing down the numbers in the union. They also
Okay.
have this concept of complement. You probably remember that. That
Yes, sir.
great. So complement is everything that is not in the set, right?
Yes,
So
sir.
good. And what sometimes they do is they may ask you for the complement of A, the complement of B, and ask you for the intersection of the complements of the two sets, right? And all that mean is
Okay.
what is common, what are the common elements that are in the complements of the sets. And the thing is,
Okay.
yeah, you don't have to stress yourself because what people tend to do is they do too many things at once. So if you can break it down and find the complements first, just as I did here, and then somebody
Mm-hmm.
asks you, so what is the intersection of the complements? It's all right, fine. First, let me find the complement of A and the complement of B. And then once I have those written down, you look again and say, all right, what are the common elements between them? And I say, oh, yeah, see there's 0, 0, 6,
Mm-hmm.
and 6,
6
and 8,
and
and
8.
8. So just like that, you found the intersection of the complements. Right?
Okay.
Yeah. And if I were to ask you to find the union of the complements of A and B, you would tell me, you just find
Zero.
you just put them together, right?
Yes, sir.
So you'd have 0, 1, 2,
One,
3.
two, three, four, five, six,
Well, no 4 and
seven,
again,
eight,
no.
and 9.
0, 1, 2, 3, 5,
5, 6,
6, 7, 8.
7. Yeah.
Yeah, 8 and 9. Right? And now here they give some exercises. So they say set A is that, set B is that, and they ask you to copy
Mm-hmm.
and complete the Venn diagram, include all the whole numbers from 1 to 10. So
Okay.
that right there is the universal set, that 1 to 10. And so basically from that, which you already,
Complete wonderment.
right? And then you're going to create this thing. So I'm going to have you work that out. Well, I guess it shouldn't be anything much, right? I
No.
guess we can do it together. Um,
All right. The intersection will
mhm.
be 8.
All right, so intersection would be 8. So we'll have 8 here in the
Mm-hmm.
middle. And then,
And then for set A, you then
mhm,
have 1, 4, 5, and 7.
yeah,
And then set B, 2, 6, and 10.
and 10, right? And we already
Yes,
know that
sir.
8 is in the middle, so 8 counts for both of them. So we don't have any problem.
Yes, sir.
All right.
So, but in the universal set now, outside of that,
Mm-hmm.
you
Very
now
good.
have 3
Mm-hmm.
and 9.
Mm-hmm. Right. Let us double check if there's anything else. So, so already have 1, 2, 3,
1.
definitely.
Mm-hmm.
So it's 3 and 9,
4.
correct. Right?
Yes.
So we're good there. Hopefully. Oh, and then there's another one. So just for the benefit of those who may watch this video and don't understand what we just did, I'm going to actually write it on the screen.
Okay.
Yes, so that just in case um, the habit can look back on. All right, so hold on a second. Let me switch screen.
Okay.
All right. So, so that it said that set A,
Is equal to 1, 4, 5, 7, and 8.
right? And then And set B
is equal to 2, 6, 8, and 10.
all right. And then we'll have a Venn diagram now. Hopefully I can draw it good enough. Same thing.
Mm-hmm.
Worst Venn diagram that ever. All right, let me try it again. Nice. That look like a flag, but that works. And
Yes,
then circle. Right? Not the best circle, but this works.
it works.
All right. So the intersection, which is where they overlap, we
Is
have
8.
8. And then we can put label this A and label this B.
Mm-hmm.
So A we know we'll have 1,
1, 4, 5, and 7.
and B will have
2, 6, 10.
lovely. And then outside we have
3, and 9.
and 9. So we'll just put them, share them up equally. But you know, we could literally put the 3 and 9 everywhere as long as they're outside of A and B. Right? And then we can put a U right here. So great. So the next question it had asked was, what is the intersection of A and B,
A
which we
and
know, which is
it
8,
will be
right?
8.
So we can use some set notation, even though they have not introduced it as yet, to say, okay, the question asks for A intersect B. So this is the question they ask, and we know this to be 8. Okay. All right. Great. So we can go on to something else. Give me a second. The next question, let me share this now. Um, Tell me when you can see it.
Yes, sir, I'm seeing your screen.
All right, it says the whole numbers 1 to 10 are organized into two sets, set A and set B. Set A contains all the odd numbers, set B contains all the numbers greater than 4. And they go down to say, oh, they say copy and complete this diagram. And then they say, what is the union of A and B? So we can look at that. So I'm going to new share to, right. Let me scroll down for some space. So it's all numbers 1 to 10 are organized. So the whole numbers would be like a universal set. So 1 to 10. So usually when there are a lot, you don't list everything, but I guess I can list them. What you would do is put like a dot dot, some ellipses, and then you put the last number. So after like the first three dot dot dot, then you could put like 9, 10, or just put 10. Because of course, after they say 1 to 100, you're not going to see me list 1 to 100,
1 to 100.
right? All right, so they say set A contains all the odd numbers. So I can just put A. You don't have to literally write set and then A. You can just put A. And that means set A contains all the odd numbers. So it's a 1,
1, 3, 5, 7, and 9.
and then B,
5, 6
a 5.
will be all the numbers greater than 4. 5, 6, 7, 8, 9, 10.
Great. And they said to represent this information in a Venn diagram.
Mm-hmm.
Mm, all right. So we have circle, circle. This is A, this is B. So first things first, what's the intersection?
5, 7, and 9.
So 5, 7, and 9.
9,
And then A now we can fill in the rest. So this section here,
1 and 2.
let me just make it clear. This section here is what they refer to as A only. So you may see that come up later. So this section is A only, and over here is B only. So it just means what is in A and not is in and not in B. That's A only. What is in A and not in B. And of course, B only is what is in B but not in A,
And not.
right? So let me
Yes,
clear
sir.
that up. Good. So over here now is, so remember the term, it is A only, B only. Because some people, when they hear that, they still think it's just set A. It's like they ignore the only part of the question, right? So let me put in the rest of A, which in this case would be A only. You would have 1 and you would have 3. So B now, this section will just be B only, which is the rest of B. We'll have what now? We'll have 6, we'll have 8, we'll have 10. And of
Yes,
course,
sir.
outside these two sets, we have some numbers that we need to put in, right?
2 and
So
4.
2 and 4. And then if somebody wants to check, a nice way to check it is count them, right? In, in this case, we can count, but you have sets that are just too many to count. The elements in a set are just too many to count. So a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we'll capture everything. So the
Yes, sir.
question then asks, what is A union B? So that is what they ask.
Any will not be.
So
Will be 1,
mhm.
3, 5, 6, 7, 8, 9, and 10.
And let us write that down. So it would be 1, 3,
Mm-hmm.
5,
5, 6,
6, 7,
7,
8,
8, 9,
9,
and 10.
and 10. Lovely. Right? So it would be everything, all the elements that are in both set A and set B.
And B.
Right? Good stuff. So let us see what else is there. So we have um, union plot and we have intersection plot. Let us move right along. Let me see, share. All right, let us see how many more questions we have. So and here they actually speak about the set notation and they give more. So it's just more and more questions building on top of the knowledge before, and it just get more and more complicated, right?
Yes, sir.
And then this is the important part, the part where you have X and you have to solve for X and then those type of questions. But for the time being, we'll just linger. I don't want every single one because after a while I get the gist. Um, 1 second. So we're here. And what they have is this one now where they actually give you the Venn diagram and it's a list set A. And all
Mm-hmm.
you're doing is just testing if you know what's going on. If you list set
Mm-hmm.
A, you realize that you have just
Set
everything in
A
A,
would
right?
include set B. Set
Repeat.
A in this case would include set B.
Yes, right?
Okay.
So remember, if they had said list A only, then A only, well,
Would be 2, 6,
it's
10.
kind of interesting because A only because B is fully a subset of A.
Of A.
It kind of weird. I would think that it includes B as well. Um, Let me think about that for a second. No, Because if it was like an intersection like that, you would say everything outside of B. All right, so A only would definitely be everything outside of B. Um,
Okay.
yeah, but since I say A is A is everything, including B. Okay.
Okay.
hmm So you'd have so two everything. So two, what, 2, 4, 6, 8, 10, 12. So that would be the list of A, and then B now would be what is in B, which is 4, 8, um,
And 12.
12. And I said, describe both sets in words. So as you can see, A represents multiples of 2. Let me check. So 2, 4, 6,
Mm-hmm.
8. Yeah, so multiples of 2, from 2
Mm-hmm.
to 12, or you can say between 2 and 12 inclusive of 2 and 12. Um, and
Okay.
then set B now would be multiples of 4 less than, you could say less than 16. Yeah, because I just mean that you do
Okay.
include 16. Or you could say um, multiples of 4 inclusive less than 12 and including 12, right? So that's how some people say it, but some another way you can say is less than 16. And
Okay.
people just know that you do include 16, so you stop at 12. Yeah. And then it's a what is the complement of A? So the complement of A is everything outside of A. And everything outside of A is 1,
Mm-hmm.
3, 5, 7, 9,
5,
11.
7, 9, and 11.
Right? So that would be that. So this one says draw a Venn diagram to illustrate sets P and Q include all the whole numbers from 1 to 15 in your diagram. So I think that's something that you could do easily.
Mm-hmm.
Um, Draw a Venn diagram that to illustrate P and Q include all whole numbers from 1 to 15 in your diagram. So you can say that the a diagram going to be filled with numbers, um, and that's no problem. That is something that we could do easily, right? So we're not going stupid.
Yes, sir.
Yeah, you can do that one and let me know. The whole numbers 1 to 20 are organized into sets as shown in the Venn diagram. And then there's a list set E, list set S. Describe each set in words. What is the union of E and S?
I don't know if it's in one.
Again, you can do that by yourself. Um,
Mm-hmm.
so you see, you have the tools now to do all of these. Um, of course, there will be some that a little tricky, but let's get to this part that says set notation. So we use U to denote the universal set. That is the set from which we are picking the members of A and B, right? I was spoke about that already.
Yes,
Um,
sir.
A intercept B, or this kind of, I guess, I don't know how to describe this upside down, I don't know, cup.
Upside down U.
Upside down U. Yeah, that's I guess the better way to say it, right? Upside down U is the intersection of A and B,
Yeah.
intersection A and B, the set of
And
members in set A and in set B, right? So we spoke about this already. So A complemented by a little dash up top, or like a little quote sign thingy up top.
mm-hmm.
Um, and this just mean a complement of A. And then A now, so A, C, B, this look like a C, but it really means subset, that A is
Oh,
a subset of B,
okay.
means that every
Every
element
element
in A
in
is also in B. And there's a
also in
concept
B.
and there's a concept of proper subset versus just I think there's another word other than just saying subset. But it's a proper subset is when A is fully contained in B. So it's not a situation where A and B can ever be the same, right? But
Okay.
yeah, you may not see that concept here. And then it's no, it just means the empty set.
Understand.
Some would say the null set, empty set that there are no elements or objects in that set. So you could have, say, if set A is even numbers, the set of even numbers, and set B is a set of
Odd
odd
numbers
numbers, then if somebody asks you for the intersection, you're going to turn up with the empty set.
will be null.
All right, and then n in bracket A just mean the number of members or elements in set A. Gone too far now. All right, so basically at that time, but oh, they give some examples here. So we can go through this one example and then call it a day, and you can try
Okay, sir.
the others. So universal set, basically 1 to 6, all numbers 1 to 6. A is 1, all numbers 1 to 4, B is 4 and 5. And they
But
ask it for the intersection. So of course, I do the Venn diagram. Of course, the other thing too, you don't have to do the Venn diagram because not every question asks you to do the Venn diagram, and it some
okay.
yeah, some people may think that the Venn diagram is a total waste of time. So it all depends on how versed you are on doing the questions, right? Because I wouldn't
Yes, sir.
necessarily do a Venn diagram to do my questions, right? If I'm not asked to, because I kind of have a little way of setting up the thing where I don't need to do the Venn diagram. But yeah, um, so now my phone is ringing. Yeah, so for this now, of course, A intercept B is 4, which is clear. So you look at set A. So without you paying much mind to the Venn diagram, you look at set A, look at set B, you see that 4 is
Mm-hmm.
common.
It's 4.
So no problem. You look at now, which other one? You look at A union B,
A union
right?
B.
So one,
Will be
two,
all of
three,
them.
4, 5. So that's straightforward. A complement now. You look and say, all right,
Will
what
be the ones
element?
outside of A
Yeah, what? Yeah, basically. So what elements are outside of A? And you see that
will have
5 and
5
6,
and 6.
right? So you make sure, so you're checking with a universal set and you do the comparison and you see that, okay, in my set A, I do say 5 and 6, so that means 5 and 6 are outside. And then
Okay.
B complement, same thing. So you get the gist. You look and say, okay, 4, 5 is here. That means everything else 1, 2, 3, and 6. And that's that. And
Yes, sir.
and they ask a question: is B a subset of A? And when you look at B, B is 4, 5, but 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 A is 1, 2, 3, 4. So
Mm-hmm.
you don't say 4. You say 4, but you don't say 5 in A,
No,
right? So that means B is not a subset
it's not.
of A, right? Since
Okay.
5 is not in A, right?
In both of them.
Yeah. All right, and that would be it. So look through the other questions in it, get some practice, and we'll move on to the more juicy questions that are further down, like here where you have logic problems and Venn diagrams. So this is where we want to get
Okay.
to, right? So the other questions up top would come more in the multiple choice, and then this now with the kind of
Yes.
questions that you will see in paper two. All right.
Okay.
So until then, next class, um,
Until Monday.
Monday. All right. So we aim for Monday. So a little bit.
Okay, sir. No problem.